So let's draw the first equivalent circuit, where please note that we are not using any source transformation. We are just combining the two voltage sources that are in series and replacing them with a single voltage source. This is my 10 ampere current source. This is 10 ohm resistance through which we have to find the current. 3 ohm, 5 ohm untouched. This 1 ohm resistance I've shifted here. In series you can shift, you can interchange the locations of the components. And this 10 volts and 30 volts I'm going to replace with a single battery. The polarities are exactly same as the second battery, and hence this is going to be equal to 30 minus 10, that's 20 volts. We are now in position to apply source transformation. You can see the first source transformation I can apply on this 1 ohm resistance and the 30 volts battery. They are in series. If I apply the source transformation, nothing changes up to this point. This is 10 amperes, this is 10 ohm, this is 3 ohm, this is 5 ohm. And now voltage source and resistance in series converted to a current source and resistance in parallel. The resistance doesn't change, so 1 ohm remains as it is. And I'm going to connect a current source. Because the voltage source has positive battery on the top, the current source direction will be upward. That means current that comes out from the positive terminal of the battery. So it's similar to that will be my direction of the current source. The value will be 20 divided by 1, so that will be 20 amperes. You can now see this 5 and 1 ohm, they will be in parallel. So the parallel combination will be 5 parallel 1 will be 5 into 1 upon 5 plus 1. So that's 5 by 6 ohms. So the new circuit will look something like this. So nothing changes on this side. 10 amperes, 10 ohm resistance. This is 3 ohm resistance. 5 and 1, they are replaced with single resistance of value 5 by 6 ohm, and there is one current source of value 20 amperes that I'm not changing. You can now see we are once again having something on which source transformation can be performed. 20 amperes in parallel with 5 by 6 ohm resistance. So let's apply source transformation. So I'll draw the new circuit on this side, keeping the current source as it is, resistance 10 ohm as it is. Okay, let us see what is going to happen on this side. 20 amperes and 5 by 6 ohms will be replaced with a battery voltage source. So let me start with the voltage source. Voltage source will be coming somewhere here. The value of the voltage source will be 20 into 5 by 6. That will be 100 by 6, and that's nothing but 50 by 3 volts. And there will be a resistance in series which will be of value 5 by 6. But you can see that this 3 ohm resistance will come in series with this new series resistance of 5 by 6, and hence instead of showing two different resistors, I will show one resistance which will be 3 plus 5 by 6, which is going to be equal to 23 by 6 ohms. Finally, we will apply one more source transformation. This time there is a voltage source in series with the resistance, so I'll apply source transformation to get current source and a parallel resistance. So this is what we have got till now. Let us now go to the next step. As we just now discussed, we will apply source transformation, which is going to be one last source transformation. So I keep the 10 amperes current source as it is, across which the resistance of 10 ohms. And now we connect a resistance which is 23 by 6. In source transformation, the resistance doesn't change. And this voltage source will be now replaced by a current source with current flowing in upward direction, because that's my polarity of the voltage source available. And the current source value will be nothing but 50 by 3, that's my voltage source, divided by 23 by 6. So that is going to be equal to 50 by 3 into 6 by 23, which will be equal to, this will be 3 to the 6, and hence it will be 100 by 23 amperes. And now you can see two current sources will come in parallel, so they will be added because they are in the same direction. So I will add the two current sources, and finally I get the circuit in which there is only one current source available, because the two current sources will be replaced by one current source. I do not change the resistors. I will take the same two branches of the resistors. Let's say this is 10 ohm and this is 23 by 6 ohm. And quickly, please recall that this were my points A and B between which 10 ohm was connected. The current source value will be 10 plus 100 by 23. So the total current becomes 14.348 amperes, and now there is nothing else we can do. We will now simply apply current division rule because our aim is to find out currents through 10 ohm resistance. So I will define this current as I10, and if you have noticed till this stage nowhere we applied any KVL or KCL because as mentioned in the question we strictly had to follow a source transformation approach. So we kept on using source transformation and reduced the entire circuit to this simple form where I can now apply current division rule and find out the current through 10 ohm resistance. So it's opposite resistance, which is 23/6 divided by sum of the resistances 23/6 plus 10 into the total source current, that is 14.348, and therefore my final answer becomes 3.976 amperes. So that's a final answer for current that flows through 10 ohm resistance.